Hello friends, today we will continue our discussion on the feature scaling. So today we will discuss about a very important question. You may have been asked about this question in your interview, or you may have been wondering like, is there any other scaling method in scikit-learn library or in the general practice other than the most popular two, like the standardization and the normalization technique? Yes, there are few other scaling method exist, so we will discuss them one by one. The first in the list is MaxAbsScaling. The MaxAbsScaler is also known as the absolute max scaling. In this methodology, the range is selected as -1 to 1 instead of 0 to 1 of the min-max scaling. So it is very close to min-max scaling, where the default range is 0 to 1, and that is obtained via mean value and max value of that feature. In the MaxAbsScaler, it is obtained using the absolute max value, and the default range is -1 to 1. The second method in this list is the RobustScaler. So if you have too many outliers, then this method is used, and this is a variation of standardization method of scaling. In this method, instead of mean, the median is used for centering the values, and instead of standard deviation, the quartile is used to get the variance. The third is like you have already done the column level normalization using the min max scaling. There is other method which is called the row level normalization, and this scaling method is called the normalizer, and this is found in the scikit-learn library, and it has three methodology like max, L1 norm and L2 norm. Let's discuss about this feature in detail in our next video. Let's discuss with some example about the alternative scaling method. First we will discuss the alternative of min max scaling. So that is like the max absolute scaler. So from scikit-learn library, let's import the max absolute scaler. So it's not absolute, it's just ABS, MaxAbsScaler, and try to define the MaxAbsScaler. And the thing is, the max absolute scaler will not take any parameter. So if you just write get params, so you cannot see any parameter it is taking to change anything. So let's define one data like train data. So I will give like very minimalistic data like 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9, and I just copy the train data to get my test data. Now I have both the data, and let's fit and transform the dataset. So fit with the trend data and then transform with the test data. So that is your normal scenario. Now you see the range is between -1 to 1. So you have not defined any negative, so you cannot see the negative value here. So let's define the negative, and you can see the -1 to 1. So the maximum value is +1 and the minimum value is -1. So in the max absolute scalar, the range is -1 to 1 and you cannot change it. And for the max absolute scalar, it is calculated based on the absolute value of the maximum and then dividing it to the each value. Like here the absolute value of the maximum will be 9, and then 1 by 9 is the value for this. And next if I just define any outlier, so it will not fit within that -1 to +1 range. So outlier will be outside that range and you cannot have any clip like parameter to clip and suppress it. So this is a major drawback of the max absolute scalar, and you cannot change the range. So that is also one drawback till the current version. Let's check about the the robust scalar. So that is one alternative to the standard scalar. So robust scalar, instead of the mean value, it use the median value to define the center. So like all the data will be centered around the median, and the median will be 0 after scaling. And the interquartile distance is like the quartile range will be used to scale the variance. So let's check first the what is the parameters. So I just type get params, and the parameter it has like quartile range 25% to 75%. You can change it 10% to 90%. Unit variance is false, you can make it true to get the variance to the 1 for all the data set in the feature. And like will centering is equal to true, that means median will be the center and it will be 0. And with scaling is like scale it according to the variance you have defined here. If unit variance is false, then whatever the quartile range based on that variance is defined. If it is true, then it will be 1. Let's that fit and transform the same data. I just write robust scalar here, what I have defined, and just check it value. So now what is the center? So let me try to, there are some attribute to check. So one is center, another is scale. So you see, so this is the center or the median value before scaling. So it is 453. Let's define the x transform as the transform value, and now define the x transform. Yeah, and you see that after transformation the median is 0, 0 and 0. So Before transformation it is 453 and after transformation is 000. Now let's fit the transform data to the robust scaler again to get this value quite easily. Okay. I just fit it and let me check the center. So this will be the center of the transformed value. Now you see this is scaled to the center 000 as you have like with centering is equal to true. And let's check the scale of it after transforming. So you see the scale is not 111 because you have one outlier. So if you just remove the outlier and then you just define it and you just transform it, and now before doing the scaling this is the center, and after doing the scaling you have seen that this is the unit variance. So now you don't have any outlier. But this method, the robust scaler method is built for the outlier. So let's check what happens if you set the unit variance is equal to true. So I just define with unit variance is equal to true. Yeah. Now I define one outlier here. You see, the outlier is not fit within the unit variance, even though you make the unit variance is equal to true. Let's check the center. I think the center is 0. Yeah, as you have given with centering is equal to true. Let's define the with centering is equal to false and let's see what happens. You cannot see the center if you have made the centering is equal to false, and same happen for it as well. And now you see, so that is not centered around 0. Now let's check the scale. So scale is also not unit variance. Let's check it. After the scaling, so it is 111. And before the scaling it is 2, 2 and 5 with some value after decimal as well. So this is the scaling method. It's an alternative to the standard scaling and it is for the outliers. Like if you have too many outliers in your data, let's give too many outliers to your data. So if you have given like this, let me define one more. And See, it's almost scaling the data to a like nearer variance.